Let's look at LabVIEW for the reverse osmosis experiment. Double-click on the most recent version of LabVIEW. And note that your version of LabVIEW may not look exactly like this. We may be making some changes to this. But it should still have the same information. You should have pressure versus time, temperature versus time, conductivity versus time, and the flow rates versus time. Over here, we've got the delta P across the membrane. We have our feed pressure here and our retentate pressure. We've got our temperature probes in the different areas. Look on the apparatus to see to which probes these correspond. We also have conductivity probes and our flow meters. Over here, we've got our Badger valve and our pump settings. The Badger valve percent open is right here. This is a slide that you can move up and down. You will use this slide to change the Badger valve percent open, and it will register right here. You can also change your desired RPM right here. You can increase it, or you can just type in values. Down here we have a pump pressure safety switch, so if the overall system pressure goes above 850 psi, the apparatus will shut down and you'll see this alarm. Here we've got the alarm for the delta across the membrane. If the pressure goes above 12 psi across the membrane, the system will shut down and you'll see this alarm. We've got our pump ready and our stop pump. In order to start the pump, you just hit the pump ready button, and to stop it, you hit stop pump. Those are the areas of interest. Let's start a run. Click on the forward arrow, and then I'm going to call this temp 1, and the run has started. The Badger valve should be at 100. If it's not, make sure that it's up at 100. We want it all the way open when we're first starting. And then our RPM that we want to start with is 100. I'm going to log this, and once I know that these are both at 100, I will start my pump. Now the pump started light has come on, and the pump has started. As soon as you turn on your pump ready button and the pump starts, be sure to immediately check your retentate line, which flows to the feed tank on the experimental apparatus. You want to make sure that water is flowing out of it. If there's no water, then you've got a valve closed, and you need to immediately shut off the experiment and figure out what the issue is. Now the fun begins. You can change the Badger valve opening and the desired RPM in order to vary your system pressure, which is up in this upper right corner. Please vary these only by just a little bit. So I'll change the Badger valve, and in the beginning I'll change the RPM by hundreds. It's going to get louder and louder. In fact, it's going to be probably a little too loud for this video, and so I'm going to change it back down. But I want you to be aware that once you get past 50 or so here, you should really move extremely slowly with the Badger valve openings. You should just decrease it very slowly, and the RPM, I would give it at least 30 seconds to equilibrate to whatever you change it to. I generally change mine by about 100 up until 300 or maybe 400, and then I change it by 50, and then once it gets around 600 or even 550, I change it by 25. If you change your RPM too high without the Badger valve being closed enough, you'll get a delta P error. So just make sure that your Badger valve is closed according to the settings that you'll see in the problem statement. Look at the problem statement to determine the ranges within which you should run. We've got a range for the overall pressure, the Badger valve percent open, and the RPMs. We also have a table that'll give you the Badger percent open for different RPM ranges. For instance, if you're running at an RPM of 500, you could close it all the way down to 10%. However, if you're running at 700 RPMs, which is our RPM max, You should not close the Badger any more than 15%. When you're ready to stop the pump, please open everything and hit Stop Pump. This will stop the pump, though it will not show it in the desired RPM. But you will see that the pump has stopped, your flows have stopped, and you'll hear it stop. If you want to start it up again, go ahead and hit Pump Ready, and the pump will begin. If you hit the stop button here, then the whole system will stop. You won't be able to start the pump again. In fact, this run will be over. You can also hit the stop button up here. If you want to start another run, you'll have to hit Run again. Let's look at our data. I'm going to open this with Excel. If you open up your Excel file while LabVIEW is running, it will air out the program. And here I have all of my data, my pressures, my flows, my conductivity readings as a function of time. When you're using the handheld conductivity probes or you're doing catch and weigh, make sure that you note the time that you take your readings so that you can compare to the correct flow rates and conductivity readings in LabVIEW. That's it for LabVIEW. And again, yours may look a little different, but you should still have the same information.